5. Your summer job pays time and a half for overtime, blah, blah, blah. You can read the problem. Okay. Write and graph a piecewise function that gives your weekly pay in terms of the number of hours you work. How much will you be paid if you work 48 hours? I didn't do that part. Oh well. Here's the piecewise function. We've got two pieces. You've got when you work 40 hours or less, then you're just going to be paid your $9.50 per hour. Then you've got if you work more than 40 hours. Okay. The simplified equation is 14.25h minus 190. Where does this piece come from? It comes from calculating it out. If you're working more than 40 hours, then you're going to get a 40-hour regular pay. So 9.5 times 40. You're going to get that 380. Now, time and a half means 1.5 times your regular pay. Okay? And then times h minus 40. Why h minus 40? Because the 40 hours are already here in this number. Simplify it and it comes up to here. Okay, the graph, here's what a graph will look like. Now remember, this is going to be possibly multiple choice test, so you're going to have to identify the correct graph by looking at slope and y-intercepts and making sure that they meet here at this point, that kind of thing. For 48 hours, all we're going to do is take 14.25 times 48 minus 190. Okay, and that is simply 14.25 times 48 minus 190, $494. Okay, and that's gross pay. You got to keep in mind that that's not the amount she's taking home, or you, or whoever. Alright, 36 says to graph, okay, and I've written a note saying to graph, see the calculator. Okay, to graph this, we just plug it in just like it says. So we've got x to the 5th minus 3x to the 4th plus 4x cubed plus x squared minus 2x minus 3. Okay, it's always best to have it on Zoom Standard. When we look at it, there it is. You're going to have to pick the right graph. 37. This one is slightly different from what's actually on your paper because there is a problem with the one that's on your paper. The minus needs to be a plus between the x squared term and the x term, and then it will work out correctly. Okay, so that's where the change is. Here's the original problem, but I've changed this minus to a plus, and now you can factor it by grouping. Group the first two terms and the last two terms. Factor the greatest common factor, x squared times x minus 2, greatest common factor, 5 times x minus 2. Now we're going to factor the x minus 2's. We took this 4-termed polynomial and made it 2 terms. They're big terms, but they're just 2 terms. X minus 2 factors out. We're left with x squared plus 5. We're finding all the zeros. So x minus 2 is equal to 0, x is 2. When this is equal to 0, x is plus or minus I square roots of 5. Okay? This is a type of problem where you could not find all the zeros in the calculator, because if you have imaginary ones, the calculator will not tell you what those are. 38, 39, we got graph paper for those. Oh, 39 is not graph paper, but 38 is. 38 is to graph this function, y equals 1/2 x minus 2 squared plus 5. Okay, 2, 5 is your vertex, and then we go over 1, up 1/2, over 1, up 3/2. And there's our 5 points. 39, determine between which two consecutive integers there is a real 0. Okay, again, we plug it into your y equals, so we're going to do x cubed minus 9x squared plus 23x minus 14. And then we can look at the graph, okay? We see on the graph that it crosses the x-axis how many times? I see 3. Okay, it's a third degree polynomial. That makes sense. So let's determine where those zeros are. We're going to go to the table. And on the table, when the y changes sign, here when x is 0, y is negative 14. When x is 1, y is 1. So therefore, we switch signs. We went from negative to positive. There is a 0 between 0 and 1. Keep looking. Oh, look, there I go again. 1 to negative 2. So there is a 0 between 3 and 4. Okay, 41 and 42 are to graph. I've got those on my graph paper. 41 is a square root function. And 42 is a rational function where you have to get the vertical and the horizontal asymptotes in there. Okay, so check your work on that. The vertical asymptote on 42 is what will make the denominator 0. The horizontal asymptote is, well, it is 5. You can see that too. 43. Oh, I'm going back to 40. 40 is we had to find the domain and the range for the function and its inverse, and find the inverse. So I started with domain and range. F of x, the function's domain is all real numbers. Okay, with domain and range, guys, you're looking for a couple of things. You ask yourself, is there an x in the denominator? If not, you ask yourself, is there an x underneath a square root or any even root? If it's an odd root, you don't care. If it's an even root, we care. If you don't have an x in either one of those, it's all real numbers. Because the denominator of a fraction cannot be 0, and the radicand, or the number underneath the radical, for a square root or an even root, cannot be negative. Okay? So that's why there's restrictions if you have that case. Okay? Now the range is, this is a parabola. It opens down, which tells me that the vertex is the maximum. So that means all the y's are going to be less than the y coordinate of the vertex. So that's where we got less than or equal to here. The domain and range for the inverse is just switched. Okay, you take the original, switch them. So x is going to be less than or equal to negative 2, and your range will be all real numbers on the inverse. To find the inverse function, change the f of x to a y, because that's what f of x means. Then you switch x and y, and solve for y. (43) State whether it has infinite, jump, or point discontinuity, or if it is continuous. Okay? Again, this is all about the domain. Looking at this equation, is there an x in the denominator? Yes, there is. Therefore, we have a restriction. That denominator cannot equal 0. So, yes, it has some kind of discontinuity. It is not a continuous function. You need to determine what type of discontinuity it is, so we need to factor the numerator. When we factor the numerator completely, we've got x times x minus 6 times x minus 5. Well, guess what? The x minus 6's will cancel. If two factors cancel, then it is a point discontinuity. It is a hole. It is removable, because you can put a little point right back in there. If it did not cancel, it would be an asymptote. It would be infinite discontinuity. And as far as jump discontinuity, you're only going to see that with a piecewise function. And this is not piecewise. 44. Descartes' rule of signs. Okay, what does Descartes' rule of signs tell you about this function? Well, we're asking about positive and negative real roots. That's what Descartes' rule of sign is. So we start with the function as it is. How many times does it change signs? Okay, we've got 2. Since it changes sign 2 times, there's either 2 or 0 positive real roots. Then we find f of negative x. When we plug negative x into the original function for x, it's only going to change the sign on the variables with odd exponents. So this is x cubed. It's going to change the sign to positive. It's not going to do anything to that x squared, but this negative x is going to become positive because x has an exponent of 1. Then we do the sign change thing. There's one sign change. Since there's only one sign change, you only have one option, and that means there is one negative real root. That's what Descartes' rule of sign says about that. 45. Find the discontinuities. State whether they are removable or not. Okay. Factor. It's not factored on your test, but you need to factor it. When you factor, this is what it factors to. You set the denominator equal to 0. These are your discontinuities. These are where your points of discontinuity are. They are non-removable because they are asymptotes. How do we know they're asymptotes? Because they don't cancel. (46) End behavior. Okay, looking at the problem, it is a positive odd function. X to the 5th is our greatest exponent, so that makes it odd, and leading coefficient is 8, so it's positive. So therefore, as x approaches negative infinity, the function's also going to approach negative infinity, and as x approaches infinity, f of x will also approach infinity. 47, describe how it can be graphed. Parent graph is x cubed. We've got 2 times x minus 3 cubed plus 1. So it's translated 3 units to the right and 2 units up. It also has a vertical stretch by a factor of 2. 49. Here you had to identify it and write the function. It's going 3 units left and 2 units down. It's a cube. So here is our equation. This is our 3 units left. This is our 2 units down. 50. Find the number of complex roots. Then graph. Well, there are 3 complex roots because it's a 3rd degree polynomial. Factor it to find the roots. Factoring it, we get x equals 0, x is negative 3, x equals 2. Okay. On the graph paper, here is what it looks like. I've plotted the zeros. We find points in between. Number 48. We are finding all the real number solutions, or the zeros or something. I don't remember what the directions say. But we've got x to the 4th minus 52x plus 576 equals 0. This one can be factored like a quadratic. And this should be an x squared right there. How I factored this is I just looked for factors of this that would add to 52. And that's really a trial and error kind of thing. I was hoping that I'd get some perfect squares, so I checked my perfect squares first. Just go through it and trial and error and find those. Then you set each factor equal to 0 and solve. You get positive and negative 4 and positive and negative 6. You could have factored it completely, because here we've got the difference of 2 perfect squares. So the x squared minus 16 is x plus 4, x minus 4. And the x squared minus 36 is x plus 6, x minus 6. And then if you set each one of these equal to 0, you'll get these same answers.